Hello. Before we get into the topic, let's answer a question. Why do we need edge computing? We are in the era of Internet of Things. Basically, all electronic gadgets we could think of are able to connect to the Internet. From mobile phones to devices at home such as lights, doorbells, or even your water bottle that reminds you to drink water after learning your daily patterns. By the end of 2025, there will be about 25 billion of devices that will be connected to the Internet from the estimation of Oracle. It is enough for everyone in the world. Cloud platform is already very popular for data sharing and processing among different devices. However, is it possible to connect everything directly to the cloud to establish the smart world made up with Internet of Things? It is possible for devices like smartphones, but what about your headphones, which also belong to a part of the smart ecosystem but with minimal capacity of accessing Internet but also need regular software updates? With Internet, we cannot stay away from the possible latency and jitter. It might not affect much if it is just within a smart home and we can wait for a few seconds when a speaker trying to reconnect. But what if someone is driving their autonomous car and the front camera detects there's an incoming object? We don't have time to wait till the signal to take a round trip to the cloud database for analysis, or something like this might happen. Now that's when edge computing comes into play, where an edge device will do some pre-processing of data before sending it to the Internet. And think of your router. It is an edge device and it is closer to us by being at the edge of the Internet below the cloud server that are designed for offloading or pre-processing some data flow to help the devices like your headphones to connect to the server, or help autonomous car to react faster to the environment, or in another word, to be context aware.
With 5G technology, applications or devices can transmit larger amounts of data in a shorter time, as networks have high throughput and lower latency compared to 4G networks. This benefits those highly interactive applications a lot, such as live stream, virtual reality, and augmented reality, which require low latency in data transmission. However, the traditional mobile cloud computing obviously cannot satisfy the requirements of 5G networks, as the central cloud server is often far away from mobile devices, resulting in high latency in data transmission, which conflicts with the property of 5G networks. But mobile edge computing solves these problems, as it brings the cloud capabilities to end users, enabling edge devices to access the cloud service in a faster way. On the other hand, there are many improvements on mobile edge computing, such as enhancing energy efficiency of edge computing services and mobile devices, since energy consumption has become an important issue nowadays. And we will discuss about it later on.
But before that, let's discuss one of the most important applications of mobile edge computing, which is computational offloading. That a mobile device can either offload computational tasks directly to the cloud or transfer the task to edge devices, which could help to offload the task. For example, a CCTV camera can capture some crucial moment when instructed by the nearby edge device with built-in algorithm, instead of sending everything it captured back to the cloud that wastes unnecessary bandwidth, and facilitated by nearby edge devices as roadside units. Autonomous car pass-by can be directed by nearby edge server with lightweight algorithm to avoid crashes. So whatever happened in the beginning of the video will not happen.
As we all know, with the rapid development of 5G technology, the mobile edge computing has become a prominent part of our daily life. Not only because the 5G technology provides the basic hardware support for edge computing, but also the edge computing technology fit in our modern life quite well with the real-time interaction and many other great features. Now I want to talk about some advantages. First of all, mobile edge computing largely reduces network latency for real-world information collection and real-time data processing. With the fact that it is at the edges where we collect all the data information, mobile edge computing will save a lot of time in the transmission compared to traditional cloud computing with only one central processor, so lower latency for better and quicker interactive real-time applications. Another good thing about mobile edge computing is that it could save a lot of energy consumption, regardless of the distance between the user equipment and the cloud. Mobile edge computing can also wipe off the complex process of data offloading, which consumes so much energy, And most importantly, it could help improve the battery life of user equipment without the use of multiple consuming sensors in data interchange process. Of course, we believe that there are actually some disadvantages or uncertainties in mobile edge computing. For example, we have to consider the ability for the edge equipment. It may not perform as well as we expect because of the lack of dataset and limited computing capability in edge server. Another thing is that maintenance of edge clouds. Instead of continuously maintaining the central big cloud in traditional way, we now need to focus on many edge servers and make sure that they're secure and stable all the time. This brings some extra burden on service developers and maintainers. But anyway, overall, advantages of mobile edge computing definitely outweigh the drawbacks, so it got great potentials in the future.
Now we are going to introduce some applications in sub-domains. Even though mobile edge computing is a young thing, it has already been widely applied. For example, Huawei and similar worked together to build an elevator management system to help monitor the state and security of all the elevators. Others have also developed a special chip which could be easily installed in different equipment. This kind of chip could continually send data to on-premises edge service, which keep communication with the other cloud. Moreover, Amazon's wavelength system tried to make it possible for all the companies to make use of the advantage of 5G network. Let's see more details about this system. After deploying the wavelength zone within the communications service provider's data center, the data provided by the user and the devices could reach the application server within the communication network. This could help to optimize the route of the data transmission. It decreases the data transfer time and improves the user experience. This kind of improvement could also reduce the power consumption of the devices and thus could increase their service life. The wavelength system has been widely deployed in many cities all over the world. So, why so many people like it? Firstly, it has high consistency, which means the same structure and code could work in different 5G networks in disparate places. This could reduce the learning cost of the developers and increase the reusability of the code. Next, it provides great low latency service for the small companies who may not have the resources to build their own edge computing network but have a great demand for low latency interest-of-things service. Also, the structure is global, flexible, and reliable. This expanded the scope of applications. The system has already been applied in smart cars, real-time games, and stream media transmissions.
Mobile edge computing is still in the early stage of development. The technical characteristics of MEC mainly include low latency, high bandwidth, and location awareness, which has broad application prospects in the future, such as autonomous cars, AR, surveillance, video analysis, video optimization, and acceleration, even in medicine and other industries. However, stable services need to be built on unstable resources, and the limitation of wireless network make MEC still face many challenges. The diversity of requirements and cases is the primary challenge. For example, technology, topology, environment, connected things, heavy or light data processing, analysis styles all need to be considered. Secondly, in terms of efficient use of resources, at this time a unified, integrated computing platform is important, on which resources are pooled and different service forms are provided. Thirdly, resources forms are not uniform. The network environment, model, and stability of each node are inconsistent. Therefore, unified modeling services should be provided for different resources. Moreover, it is essential to ensure the security of the edge computing platform. Unlike mobile device security, MEC nodes are more heterogeneous and complex, adding additional delay in encryption and decryption, which requiring better monitoring and protection. To sum up, build the infrastructure and operations for MEC. First should create a dynamic strategic plan, approach, and framework for it that balances requirements within manageable guidelines. Also ensure that a proof of concept deployment can handle the actual management scale, connectivity, security, computing, and storage.